Alright, so here's the thing. There are two things. One, the real physical reality out there, and the other thing is the model that our brain or our intelligence conjures up or develops of that physical reality. Now, why does it develop a model? Well, these models are sort of a map of the physical reality out there. And these maps of the external reality out there helps us navigate the physical reality. The thing is that the reality is highly uncertain or probabilistic in nature. And to maintain the existence, the intelligent being tries to figure out the probabilities or uncertainties of the external environment in order to maximize the chances of its survival. So this calculation of uncertainty or probability or weights is what our intelligent systems are doing. So basically this brain of ours is just a probability calculating machine or a probability calculator which calculates the probability of the actions that would help our existence and those actions that would uh, potentially put us at risk. And it also calculates the probabilities of the external factors that would harm us or that would help us extend our survival or existence. Now we have senses to map the external environment, but that is not sufficient. So as the system evolves into a more intelligent system, what it is trying to do is trying to extend its uh, you know possibility of survival, its potential of surviving. So in order to do that, uh, you know, in addition to our senses, we have developed this intelligence so that our maps of the world out there becomes much more larger and much more, close to what reality is. Now, as our models that we have developed, the intelligence system has developed, becomes much more representative of the real physical reality out there, the more it helps in surviving the reality. And so we refine our models, we refine our maps by collecting datas, which the AIs also are doing now. So we collect enough data, we learn, and we refine and refine our model to better represent the reality out there. So everything that our brain or this intelligence system has developed to better understand the reality out there is a model. And so from mathematics to other languages that in which we communicate and the other languages or models in physics, for example relativity and quantum mechanics, these are all models to better understand the reality. We are refining our understanding of reality by collecting more and more data, by understanding the reality much better. And that is what our models are doing. They are becoming much more better representatives of the reality out there. Now nature or existence has done a very great job through evolution to develop these systems and these intelligent systems which develop these models to better understand reality. And that is something that is it's wonderful. Now the question is whether we will ever discover a model, or whether we will ever figure out the model that actually describes the reality in its full essence, completely. Whether these theories of everything or theory of everything is even possible. And I think that these theories of everything or theory of everything may not quite be realized ever. That is, it does not exist. And here is why. So here is why I think that is the case. Now the analogy that I most often use is that of the simulator and the simulation. The simulator can never be exceeded by its simulation. So simulation is a subset of simulator in a sense, and this simulation will never be able to overcome its simulator. And so our models, whatever our intelligent brain or intelligent system creates, these models are just models, and they are simulations of the real physical reality out there. And to be able to come to the exact weights of the reality, external reality, we have to have or be trained on the all the possible data that is available out there, and that is virtually impossible. So it is like attending to or tending to infinity. So it is like tending to infinity. So we can obviously approach and refine our models further and further, but we will never be able to fully simulate the external reality itself within these models, or as these models in our brains, or in any intelligent system that is a part of this cosmos. So we see that for these models and these simulations of the external reality in our brains or any intelligent system, these for these systems or for these models, that external reality is sort of like infinity, at infinity. So it can obviously approach that, but it will never come to match this external reality. So these intelligent systems can train themselves with more data from the external world, train themselves on weights, and they can refine their weights to approach the actual real weights of the real physical reality out there. So training with more data will refine the weights of our models of our language to better represent the actual weights or actual language of the universe or of the cosmos or the physical reality out there. But all we can do is refine our language to come to exact representation, to approach the exact representation of the real physical language of the cosmos, of the nature, of the existence itself. But the language or the model that our brain or any intelligent system that refines it and learns it and makes it much more representative of the actual language, actual physical language of the universe, is it's just gonna refine, but it will never be exactly the same language. We can never learn this language of universe, this physics, or this physical language of the universe exactly, just as these AI systems, unless they become more intelligent than us, they will never be you know uh, fully capable of grasping our language. So yes, the models that we have, or any intelligent system will have, uh, the language that they are, learning, the language of universe, that is physics. You know, so this language, they will learn, they will gain more data, and they will be able to learn and refine their, language, and make it much more better representative of the actual physical language of the universe. But no intelligent system will be able to learn the true nature or true language of the of this existence. So in other words, the weights of the language or models of any intelligence system will of course tend to the actual weights or language or model of the existence of the cosmos, or universe or multiverse or whatever. So it will obviously tend to, but it will never be able to exact or go beyond, unless that intelligence system itself becomes something that is much more greater than the universe or the multiverse itself. So we have these intelligent systems that are trying to learn the language of physical reality, that it that that is these intelligent systems are trying to learn physics, obviously, this language of physics, but they can never completely learn this language, uh, because any model that they are developing to represent this language, any language that they are developing with particular set of weights, these will obviously have limitations because of the reasons just mentioned before. So they will have they will represent they will be better they will be better at representing this language of physics, but they will never fully comprehend the language of the physical reality. And these limitations of the models or language or weights of these intelligent systems that are trying to learn the language of physics of the physical reality, these limitations of their models is what singularities in these models are. Now every model or language that these intelligent systems have developed has singularities in them, these limitations in them, and if you try to explain, or if you try to you know speak something or try to predict something using these models about the actual language out there of the physical reality, when you try to go beyond these limitations in trying to predict these things about the physical reality, then you get an error in these models, and these models show some kind of infinities or other contradictions and all sort of things, and these are their corresponding singularities, and these are there because you are trying to use that model to define something, to predict something of the physical reality out there that is beyond that model of or those models of those intelligent systems. And that is what these limitations or singularities tell you, these infinities and contradictions, these sort of things. So in mathematics we have Gödel's incompleteness theorem as its singularity, and in other models of physics, for example in relativity we have black hole singularities and the Big Bang singularities, where you get infinities and all sort of things. And in other communicating languages, or in other languages that we use to communicate, in these also you come up with some sort of contradiction. So for example, let's try in English itself. So when I give you a statement, quote unquote, everything is temporary. So now the question is whether this statement that everything is temporary or not. And if it is temporary, then that means you run into this whole sort of permanent temporary contradictions. So when everything is temporary, and even if the statement that is claiming or telling that everything is temporary, becomes temporary, then so temporary, the status of temporary itself becomes temporary, and so there is permanence as well. So again you try that whole thing, and you get contradiction upon contradiction, and you just revolve around and revolve around. So these contradictions, these singularities, these infinities, and incompleteness theorems, and all that, these are the limitations of our language, of the limitations of the models of these intelligent systems, and they produce these singularities or errors, or infinities, or these sort of things, contradictions, when we use those models to predict something of or something about the actual language of the physical reality, or of this physical reality. And when you try to predict that, these languages are not equipped sufficiently, or that thing that we are trying to predict is beyond the bounds of the models that we have. And so you are trying to basically go beyond these models that intelligent systems have to predict or define something of the actual physical reality, of the actual physical model out there. And so when you try to define things that are beyond these models of our of these intelligent systems, and these predictions about the actual physical reality or the actual physical language, so when you try to predict this, you get singularities, infinities, and all sort of crazy things, contradictions, because those things are beyond these models that we have, that these intelligent systems have. And so for example, in case of these large language models, or ChatGPT and all sort of things, when you try to go beyond a certain point, you get all kind of gibberish. These AI systems, they produce long sequence of nonsensical things. So that is what sort of is happening. Now every model will have singularity and limitation, so we can never come up with the theory or model or language that is an exact representation of the physical reality out there, um, unless we have some sort of intelligent system that goes beyond the so-called quote unquote out there, and makes it the in here. So it has to become like these intelligent systems should become the the superset, or the set of which this physical reality becomes a set. So these but anyway, this set and subset kind of thing will always remain, and one will never exceed the other. That's it. Now I think the problem with our inability to understand uh, quantum superposition is because our brain, or the classical way of our thinking, and all the language or all the models that we have, they are sort of classical or traditional way of thinking, in which we sort of think in terms of binaries, or we think it as you know in terms of binary thing. So we have a binary situation here, and this you know when we think in terms of binaries, or binary way of thinking, will or these models that are based on this binary logical system will always fail to grasp the quantum superpositions, because this quantum superposition is something that uh, the physical model, or the real physical language has, and our language or our models that are classical and that work in this binary sort of way, they fail to recognize or understand these actual way in which or actual uh, patterns in this real physical language out there, and our models are just binary systems. Sorry, our models are just they think, or their basis is in terms of binaries, and so whereas the physical language, the real language of the universe, of the cosmos or existence, is not in terms of binary. And so these binary models that we have, and by the way, every model that we have, every classical model or any other model, the mathematical way of thinking, they are all binaries, and they sort of think in terms of binaries. So these models that are all, and these are all based on binary situation, a binary sort of way, so our way of thinking. So these models will never be able to comprehend what quantum superposition is, which is beyond these binary models, and which actually is what the physical reality out there, or the physical language out there, there out is like.